Welcome back to another recorded interview. As you can see, we are both working from home. And so this is a new style for interviewing. But today we thankfully have Fang, who is, I believe, our co-founder. Is that correct, Fang?
Yes.
And, we are going to be talking about a lot of the exciting news that is happening at DataVisor. But first and foremost, I wanted to get your feelings on being recently awarded by Gartner as a cool vendor. It was for innovative use of unsupervised machine learning. So can you tell us, what does it mean to be awarded that? And then what makes our approach so effective for our customers?
Thank you, Eric. I'm very glad to be here. We are very thrilled to actually get a cool vendor from Gartner, and it's actually recognition of our unsupervised machine learning that we're very honored. And then it's actually unsupervised machine learning compared to others actually are a little bit less known. And it's very great to actually get the recognition. Maybe let me actually give you a little bit background of what is unsupervised machine learning. In modern machine learning fields, there are different type of the solutions, right? Especially for fraud detection. There is actually the rule-based solution that everybody is actually familiar with. You see something bad, you actually write a rule that precisely that type of attack will be stopped. And then recent years, there's also supervised machine learning solutions, so that when there is actually fraud labels, you don't have to write rules anymore. The model will actually help you capture those. It's actually much easier, and it's able to capture sometimes even more than the fraud, the rule solution. And then there's actually this brand new notion of unsupervised machine learning that DataVisor advertised a lot. And then this is actually able to detect fraud patterns without actually using the labels, because all of these previous approach based on labels, it's always reactive. And unsupervised machine learning is able to get this fraud patterns detected without labels. So why without label is actually very, very important for fraud detection. So fraud detection is actually, I would say, it's a specialized field. In many cases, the machine learning field, if you look at the image recognition, the voice recognition, it's actually very, the target is actually very clear. So, for example, in the image recognition, you want to recognize a cat, right? First, there are a lot of samples. There are types of cats everywhere. And then the second is that the cat doesn't change much. So you will see from cat looks like thousands of years ago versus cat look like now. It's almost exactly the same. They may be new species, but the overall look is actually pretty similar. But for fraud detection, it's very different, right? First, you don't have so many examples. In many cases, the fraud percentage is well below 1%. So it's very, very small, like a rare event, and sometimes even below 0.1%. So it's very, very low events, like a needle in the haystack. And you don't have so many examples. And what this fraud look like changes every day, because fraudsters are very proactively looking at it and they try to change its behavior so it can evade the new method every time. So it's intrinsically very hard compared to the other target of the machine learning. So that's why the unsupervised machine learning comes into place. Very, very even more important in the fraud detection field is because first, we don't have a lot of labels. Second, the label often comes very late. When we actually have it, it's going to be it might be obsolete. That's why the unsupervised machine learning, when it applies without label, can capture something brand new. It's ultimately critical for our customer to able to detect these new attacks.
Well, I mean, it sounds like it's a little bit hard to understand almost, because it's such a new approach, right? Like it's very different than anything that's been going on before. Compared to the more traditional approaches like rules and supervised. So what have been the main challenges that you've encountered with the adoption of this? I guess, the fear of the unknown, if you will.
Yeah. So I think we encountered a lot of challenges when we actually first talking about unsupervised machine learning. It is like you said, right? This concept is so new, and then it almost sounds like magic, right? People ask me, how would we actually, without any label, detect fraud, right? It is like, are you like a magician able to do so? What are the intrinsic reasons you can do that? And also, there are also people actually taken the unsupervised machine learning as one of the traditional anomaly detection methods. Anomaly detection actually has been in the field for many years for fraud detection, for security breaches. So anomaly detection is something that you look at the user's behavior and then you set something base, and anything derived beyond the base, you think that's actually something suspicious. It works pretty well in terms of many attacks it can capture, but it actually has very high false positives. Because first, normal user is actually very long tail behavior, right? You can say most people actually doing transaction in the daytime. They go to the branches, they're doing this. But if there is actually someone in the middle of the night doing a large wire transfer online to a foreign country he never actually sent money to, that's definitely an anomaly. But if this is definitely fraud, it may not, right? They maybe actually have some family emergencies. So they have a friend actually overseeing some money. So this is actually very, very legitimate. But anomaly detection will capture these. Why people constantly show anomaly detection associated with high false positive. So you may actually have a high false. And the high false positive is actually very, very critical problem for the financial institutions or even everybody. Because when you stop a transaction or you stop some users, the users will actually be very annoyed, and it hurts good user experience. And then some users will actually make a call to the call center to add pressure to the call center. So it's actually very bad. People do not want that. And then so we actually have to explain the DataVisor's approach is actually very, very different from anomaly detection. We're not only looking at the single user, but we also look at a group of users. Maybe let me actually give you a little bit background on how unsupervised machine learning detects fraud without labels. So this sounds like a magic, but what's the actual underlying rationale behind it? The underlying rationale behind it is that for the fraudsters, they typically do not do one-off attacks because they are mostly want to gain a financial reward, right? And then when they actually conduct one attack, then when they actually see it, they must want to conduct multiple attacks that actually so that they can maximize their financial gain. And in many cases, they may even want to do many because one shot of an attack before the new rules kick in or the new models actually capture them. So this actually drives. So there is actually a lot of similarities in terms of these fraudsters' activity. So in each individual event or each individual user account may seamlessly look at different. They may actually come from different IPs. They can come from different devices. But in the back, they are actually controlled by these fraudsters groups. They are sophisticated fraudsters. They remotely control these groups. But intrinsically, because they want to conduct a similar type of attack, and they know specific ways this attack can go through the existing system, there are a lot of similarities among these activities. So if you look at these activities, not only look at a single event, looking at a single user, but you zoom out, looking at all the users' behaviors, and you are able to see these correlated clusters actually coming out, and they are connected. If you look at the graph analysis, they are connected in a suspicious way. So that's kind of a rationale behind the DataVisor's unsupervised machine learning techniques, that we are able to actually use these techniques to identify the suspicious linkage and able to call out this is actually a suspicious ring. So when doing that, it's actually highly accurate because we're not based on the single user. This is actually deviated from the norm, and then it's also very easily explainable. Saying why are we actually capturing this? This is actually because this group who are the group members within this, and then what are the behaviors that's actually very different, and then suspicious behaviors that we conclude this is actually a suspicious, this is a fraudulent ring. So in doing that, it's high precision and also easily explainable instead of actually some other traditional method. We'll say the deep learning model, this different neurons, very hard to explain. With this, our DataVisor's unsupervised machine learning techniques, we are able to give precise reasons, and then the people can see why we actually capture those.
I mean, that seems like, especially in the world today where everything's been digital, especially over the last 2 months, really, really important. And I think that, most businesses are probably looking for things like that. So what would you say are some of the best practice recommendations for how organizations can get started with UML?
Yeah, so as you said, last 2 months is very, very special. I think a lot of people actually the speed of going online, going digital is never seen before, right? So when I would recommend people actually starting using UML in different points of the life cycle of the users. Very easy to start is actually at account registration or account application, for example, the social account, or they're applying for credit card, because at their time, it's the user behavior is actually pretty simple. It's just like one registration event, and then we are able to identify these. Then I will actually push that the full life cycle protection. So the power of our unsupervised machine learning is actually able to look at all the users' behaviors, how they registered, how they log in, how they actually conduct the transactions, or send out messages, or even write some posts, etc. All of these, they can actually be put together, and so it will have a complete life cycle protection. Because oftentimes it could be a good user, but their accounts are actually taken over. So in those cases, the login behavior is actually very important, and also sometimes when they actually log in, because these fraudsters typically have the underground network, they can have one set of people actually trying to take over. Some other people actually, after they take over, testing this account, they will resell this account to somebody else. So that actually we can look at and monitor how it's logging, and we can also monitor how it's follow-up actions. So it will be a continuous monitor of all the users' actual history, and then applying the unsupervised machine learning on every single point. But we can get started with we're not necessarily actually putting everything together. We can start with the registration, or start with the login, or start with some transaction. But gradually, in the end, I think it's a big data analytics time. So we should really put all the users' actually information into it, and they're able to run this the detections in real time for many of the cases. Yeah.
Yeah. No. I mean, I think that makes a lot of sense. And it's a really new topic. Like we said, there's a lot going on with it, and definitely to your point, over the last 2 months, people have certainly expedited that trip to straight digital. But with us, here at DataVisor, we've got a lot of initiatives going on with the organization to build our own machine learning solutions. And why are people choosing to buy from us instead of building it themselves?
Yeah, I think that there are a lot of actually the initial internal buildings. There are two particular reasons I think that the enterprise should consider vendors like DataVisor. The first is that because we serve a lot of clients globally, we are actually protecting 4 billion user accounts across the globe. We have a lot of I would say the information regarding the newest fraud attacks. So the consortium data, we actually see what are the newest fraud attack patterns that we are seeing. So for example, what type of the regions, what type of the devices, so what type of the the newest the IPs of the data centers, what are newest tools they are using. All of these informations will be actually able to contribute and help many of our customers to actually identify, because they can benefit from their peer information, what are the newest patterns. The second is that so for building fraud detection platforms, it's actually a lot of work, especially for unsupervised machine learning. For supervised machine learning or the rules engine, it's actually easily parallelizable, because when you have high volume of users, you can easily parallelize. So based on the user shot, right, the different user can come to different machines. So if you have more users just twisting up more machines, so that they're able to identify these patterns for you. But in unsupervised machine learning, especially with DataVisor's pattern unsupervised machine learning solutions, it's not only looking at a single user. We are zoom out and trying to look at the linkages in real time for different users. So it's actually very, very computationally heavy, and it's a lot of engineering overhead actually building this. Because in the real time, you want to actually looking at not only the single user, their past history, but you're also looking at all other different users and trying to see whether there's correlated behavior. And then within a 50 millisecond or 20 milliseconds or whatever the milliseconds you want to actually give out the answer, whether this user is actually a part of the fraudulent rings, and whether there is actually a brand new fraud pattern happening. That's actually a lot of work in terms of doing that. So it's a lot of the engineering effort to actually make DataVisor successful. Is actually make this system highly scalable, highly distributed, and able to identify new attacks. And then to add on that, I think beyond unsupervised machine learning, we are also opening up our platform to let end customers to use to build their own unsupervised machine learning models on our platform. So then I think for our customers, most of them have a very deep domain knowledge of they know their business best, right? If there is actually a new data source coming in, or if there is actually a new feature coming in, they can actually easily integrate it in our platform. So, and they're able to adjust the models or adjust things. So we are very transparent in terms of the model building, and also transparent into the features as well. Then if they have new ideas for the features, we allow them to actually build these features in real time with a few mouse clicks. Some of these features typically they need IT to develop it for them. But the DataVisor platform allows them to build these features in real time and backtest these features, and then immediately actually see whether these features are actually useful, and one click then deploy into production. So these are all very, very important for the fraud analyst, able to have a real-time impact on the problem that they have, analysts or operators. So we feel these are very, very important to actually empower our clients to able to discover more and react faster.
Well, I mean, there's obviously a ton of reasons to go with us, I think, at this point. But I know that we've got a ton of initiatives going on, and when we talk again in maybe 2 months, it's going to be completely different. So I know that this won't be the last time we talk, but I appreciate your time today, and I appreciate everyone tuning in as well. So thank you again for your time today, Fang. Appreciate it.
Yeah, thanks for everyone.
Thank you.
Thank you.